We are the proud participants of the research team Snow Whores during this week's History of Winter. During the week, we collected data and studied snow pits, thermocrons, the ecology of winter, snowflake analysis, and ice core sampling. Each set of information contributes to the bigger climatic picture. In order to have a foundation to put the other pieces of the data puzzle together regarding the history of winter 2014, we pulled weather and climate data from the closest weather station at Saranac Lake Airport in New York. We retrieved this data from weatherunderground.com. This website allowed us to create graphs highlighting temperature outliers. We also collected daily weather data from 11/25/2013 until 2/11/2014. Then we summarized the climate in 30-day increments to get an overview of the weather during this time period. Later, you'll see how this data helps understand the ecology of the environment, the relationship with the thermocrons, the snow pit analysis, and lake ice core alignment.
Our snow pit had 6 layers. We determined the layers using 2 methods. One using the snow card by passing the card down the snowpack. Changes in snow resistance was easily determined. The second used sticks by poking them into the pit. The snow card and sticks produced the same layers. You can see our positioning of the temperature probes in the layers of the snow pit. Kirsten is measuring the snow densities and temperatures. Our group used Laura's snow density pan. It seemed to work much better than the tubes. We felt very special. The total volume of the pan was 100 cubic centimeters. This is the card used to record the field data. And the final graphic is used primarily for avalanche recording. Our profile showed that the snow was made up of hoar and mixed. The surface looked windblown. The air temperature was 18.6 degrees Fahrenheit, and it was a beautiful sunny day. The temperature of the layers can be seen as the red line. Note the temperature spike of 16 degrees, and the density can be seen with the green line.
Next we have the thermocrons, also called eye buttons, and it was data that was collected at Cascade Lake, and it yielded the following findings. They were placed out in the snowbank from November the 25th, 2013 until February 2nd, 2014. During this time, they took data once every hour for every day. So what we did is we took this data and found the average for each day at each specific level, and they were spaced out at 10 centimeter intervals. During the snow pit dig, we noticed a warmer layer within the snow levels, which was the second layer from the top, at 58 centimeters from the bottom of the snow pit. The reason why this layer was warmer was due to the fact that it was insulated by the newer snow that had been deposited above it. Next, we found this layer and graphed the averages from all the days in which that leveled thermocron was out in the field. But due to the sporadic jumping motion of the graph, it shows that the data collected during these days was not covered by snow. This snow layer was deposited after the thermocron stick was removed from the site. And that is what you're going to notice on the single graph. You would see a leveling out effect in the graphs to indicate a constant temperature if the thermocron was then covered by snow. The next graph that you're going to see is the 3-layered graph that shows you the bottom 3 layers temperature over the data collection time. Finally, the final graph shows all of the thermocrons from 0 centimeters to 90 centimeters and the average day data over the period of the collection time.
Next we go to Cascade Lake and talking about its topography. Cascade Lake is located between 2 large hills. This causes less sun to reach the surface of the lake during the winter season and decreases the temperature of the atmosphere right above the lake surface. Snow was sparse on top of the lake ice due to the rapid winds, which is now being deposited along the shores. Cascade Lake has had an overall record of thickness of 78 centimeters. In the 2013-2014 season, our thickness was measured to 66 centimeters. The newest ice is on the bottom of the core, and the oldest ice is always on the top. The chainsaw was not able to penetrate the thickness of the ice, and other techniques were done in order to bring out the core from the lake. How you can figure out if the ice is safe is using a simple equation. P equals 50 times T squared, where P equals pounds and T equals ice thickness in inches. We found that we can hold 31,631.2 pounds on Cascade Lake. The ice core itself from Cascade Lake indicated clear temperature periods of cold spikes. These were noted from the high bubble concentrated areas of the core. We also observed stretches of the ice core that were very clear, indicating long periods of undisturbed slow freezing. The following images show a correlation of the ice core sample to weather patterns. Working backwards, we were able to match up cold spikes in weather with bubble structure in the ice, as well as long chilly times of slower ice formation indicated by the clear ice sections. After this analysis, we were then able to use the polarizing sheets to observe the crystal structure of the ice. The gray, black, and white present in these sheets indicated the ice was not seeded and the C-axis was in the vertical structure.
Winter ecology at Cascade Lake. First, let's start off with the hardwood. It's a hardwood conifer mixed woods. This represents a transition between the lowland conifer and the northern hardwood communities. Dominant species include the red spruce, the balsam fir, the eastern hemlock, red maple, and yellow birch. The percentage of spruce and fir is greatest at the lower elevations, as you'll see in the picture, with red maple and yellow birch increasing on better drained areas of the slope. Eastern white pine appear sporadically in small groups. The upper limit of mixedwood forest is marked by the disappearance of balsam fir and its replacement by American beech. The soil at Cascade Lake is very rocky, moist, and generally shallow compared to the spruce flats that we see at Northwood School. The decomposition here is slow due to damp, acidic conditions on the forest floor. You'll also see an accumulation of needles and other organic materials. There are many mammals in the Adirondacks. We did not see many, but we did see evidence of some. On this first slide here, you'll see a track of a white-tailed deer, as well as a list of the mammals that are present. There were also snowshoe hare tracks that we found in the woods, as well as on the right, a shelter. Birds in the Adirondacks. There are over 100 species of birds, 4 different types: boreal birds, birds of prey, perching birds, and waterfowl. Below is a picture of an American goldfinch, which we saw today. Here are 3 other birds that we have seen in the area. First, we have a barred owl, a blue jay, and lastly, a yellow-bellied sapsucker, which is a type of woodpecker.
On Thursday, Catherine showed us the different varieties of snow and its shapes. We were shown the different locations in the atmosphere from which each snowflake can form, moisture and temperature dependent. Afterward, we were able to go out during a snowstorm and observe the flakes that were falling. A variety of flakes were falling, including those you see circled on the chart. Our research team is truly appreciated this week in Lake Placid.